Why is that? Because we're doing reflections today. Oh, now it makes sense. All right, look, we have a reflection of the word reflection, and there would be a line of reflection down the middle here. But what you're going to have to do is start taking some of these notes. Pause the video as needed. Okay, I filled it all in, and we're going to look at it. You're going to have to pause it because yours is kind of blank. So we're going to start at the top. We're going to review what an isometry is. Remember, an isometry is where your image is congruent to your pre-image. Same size, same shape. All right, so if you look at this, we had a reflection over this line, and it's like a flip. It's like flipping a pancake. We love flipping pancakes here in Baumholder. It's like flipping a hamburger. Mr. Bruss did that through most of his life. It's flipping anything, but the thing you have to be aware of is points that are close to the line stay close to the line. All right, and points that are far away from the line end up further away from the line. Now, one thing that does happen when you flip is the orientation changes. So what is the orientation, you say? Well, the orientation is if you go around the triangle clockwise, the first image, the pre-image, the points go A, B, C, A, B, C. But after you flip it, if you go clockwise, then they change. It goes A, C, B, A, C, B. You'd have to go the other way if you wanted to go A, B, C. So you have to be aware that the orientation has changed when you flip it over. Other things you have to know. How do you write this? Well, we write that triangle ABC has been mapped to triangle A prime, B prime, C prime. You can use words if you want to. So what are we going to do? We're going to start reflecting in a whole bunch of lines. Okay, reflection flips an image. All right. It also may be flipped over. We're going to flip over the x-axis, the y-axis, and other lines like y equals x, that's popular, x equals 2, not so popular, but you're going to have to know what it is. The best way to do this is to get a piece of graph paper, you graph the image, you graph the line, and then you do some counting, and I'll show you how to do that in our first example. But first, we need to review the different types of lines. All right, so what kind of lines do we have? First, we're going to start with the axes. The axes are probably the most important. We're going to flip the most amongst or over those. So the first one we're going to look at is the y-axis. That one goes up and down. And the one on the right is, right to left, is the x-axis. Now, you're going to have to write these down. I know that I have them all on here. That's so I don't forget any. Okay, but you copy them on your page. Use a straight edge so it's nice and neat. We don't need any of that, bootleg line, all scribble, wibble, and all that kind of stuff. All right, so we have our axes. Most students are pretty good with the x-axis and the y-axis. Now, what else do we need to know? Well, we need to know what vertical lines, what their equations are, because you might get a problem that says flip it or reflect it over the line x equals -4. That's a vertical line right here. You're going to have to know that. If you draw it left and right, you're going to get the whole problem wrong. So make sure you understand equations that are x equals some number. They go up and down. So this equation right here, ooh, not that one. That one's tiny. This one right here, we have x equals 1. That is a vertical line as well, 1 unit to the right. What else can we have? Well, if they're not vertical, they could be horizontal. So here's a line right here that crosses at 2. That is the line y equals 2. Okay, what if the line crosses at -1? Then its equation is y equals -1. All right, there are two more that we need to know. Y equals x is the first one. Now, I'm going to do a little, we're going to write this out. Y equals x is the same line. Now, let's do y equals mx plus b. Y equals mx plus b. Now, that's how I have to write it if I'm going to write it in y equals mx plus b form. It's y equals x. There are no extra numbers, and the slope in front of the variable here, the number in front, is a 1. All right, so this line would have b is equal to 0, and the slope is 1 over 1. So that means it crosses at 0, and you go up 1 over 1. So that's this line right here. Okay, so let's draw that line on our paper. And what if it were y equals -x? All right, so y equals -x, everything's the same but the slope. So y equals -x. Well, b is still 0, and m would be -1 over 1. So you start at 0 and you go down 1 over 1. All right, so that line's going from left to right, but it's going downhill because it has a negative slope. All right, so remember those algebra lines? Ta-da! Now, what do I have? I have a huge page full of lots of lines, but I put this in here so you can look at it as a reference. So if you need to know what the line y equals 2 is and you're not quite sure and you might forget, go back to this graph. Y equals 2 looks like this. But it's not just going to be y equals 2. They might tell you y equals 5. All right, so that would be up here. Whoopsie. A little sloppy with my pen today. That would be way up here at the top. They could tell you x equals 3. Okay, x equals 3 would be vertical, and now you have lots of different examples to help you with that. So now that we know what the lines are, we're going to do our first example. It says graph and reflect the pre-image triangle ABC in the x-axis. So the first example we're going to reflect in the x-axis. We're going to make sure that we use a straight edge and we label all the points with A, B, C, and A prime, B prime, C prime. So pause the video and graph the pre-image, which is simply A, B, and C. And let's see if we get the same image. Go. All right, how'd you do? As you can see, we have a nice little triangle here. A, B, and C are labeled. Now we have to reflect in the x-axis. So what I'm going to do is I'm going to draw a line right here on the x-axis so we can focus in on the line that we're actually reflecting over, or we're flipping over. Now, here's the easiest part, or the easiest way that I know how to do this. If you're going to flip over the x-axis, you graph the pre-image. We did that, and now it's a simple counting game. So here's point B. Okay, count 2, how far is it to the line that you're reflecting over? So it's 1 unit. So we're going to go up 1 unit, and we're going to put the image of B, and we're going to call it B prime. All right, how about C? You go straight at it. You can't go diagonal. You got to go straight at it. So 1, 2, 3. So we go up 1, 2, 3. All right, now how about A? Now A is on the line, so A prime is also on the line. So I'm going to do a little trickery here. I'm going to put A down here and call that one A prime. There you go. See how we did that? Labeled both. Now, if I draw my triangle, let's use a different color here. Okay, so this is what I get. I get a nice triangle here. That's the image. I connect the points. Notice the orientation changed. If you go clockwise, the one on top goes ABC, but the one on the bottom goes ACB. So it's flipped. We have the x-axis. I labeled it so that everybody knows what's going on. Hey, that's it. It's that simple. And now if you notice, if you were going to flip the paper, or fold the paper, let's fold the paper in half, the blue triangle would end up on top of the black triangle. And they are the same size and shape, so it's an isometry. They're congruent. Let's try the next one. Example 2, graph and reflect the pre-image, ABC, in the y-axis. Why don't you try this one all by yourself? It's going in the y-axis, not the x-axis. Ready, set, go! Hey, I'm going to come in halfway through here because it's a little bit tricky. I'm going to look, hey, I got a little typo up here. Look at that. There should have been an A, but I think that's changed on your paper. So what are we going to do? Reflect in the y-axis. So we need to label the y-axis and make sure you make it a little bit darker so we know what we're reflecting in. All right, so I did that, made a nice little line there, y-axis. And now, as I said last time, you just count how many units to the line and go the same distance on the other side. So A prime is 5 units to the line. Or I'm sorry, A is 5 units to the line. A prime is also 5 units on the other side. Okay, we're going to go down to B and do that. Point B is 4 units from the line, so you go another 4. And point C is a little different in this problem because instead of going left to right, we're going to count right to left because it's on the other side of the line. It's on the right. We got to reflect it back on the left. That makes it a little bit tricky, but we're going to put it right there. Notice the different colors do help because when you connect the lines and you make your triangle, you can see them more clearly what's going on. You don't want to have a whole big mess on there and get confused about what you're looking at. So maybe you want to use colored pencils or a pen and a pencil, something of that nature. All right, so we've talked about what the graph looks like. You have the line of reflection here. It looks like everything has been reflected fairly well into the other side. I want to take a second and look at the coordinates. Those are the numbers that are assigned to the points. So like our first point is A, which is at -5, 1. Okay, where does that end up? Okay, A prime, where did that end up? That ended up at 5, 1. All right, how about B? B is at -4, -3. We go back 4, down 3. That's down here. Where did B prime end up? Well, B was mapped to B prime at 4, -3. Okay, we'll do one more here. Point C is at 1, 1. And that was mapped to C prime, which is at -1, 1. All right, so what do we notice here? Let's look for a pattern. What do we got? The numbers look the same except for negatives and positives. In fact, when I look even a little more closely, the y coordinates never change. There's no difference in a and a prime, the y coordinates. So if I take any point, x, y, I can find the reflection in the y-axis. I know that the y doesn't change, so I'm going to leave it a y. Okay, what about the x? Well, you make it the opposite. It was -5, it becomes +5. -4, +4. All right, so the x you make negative. So using the notation that we did before, we can have a mapping from xy to -xy. That is a reflection in the y-axis. You know what's weird is y doesn't change, the x changes in the y-axis. Okay, and that kind of makes sense because you're not moving up or down. So the y does stay the same. You're moving left and right when you reflect. All right, so wouldn't it be nice if someone summarized all these rules for us? Ta-da! Here are the common rules of reflection. So I went through a reflection in the x-axis. Well, guess what happens if you do that? xy goes to x negative y. Reflection in the y-axis. xy goes to negative xy. So let's take those two and just look at them for a second. The only difference between your original point and your new point is you make one of the numbers, one of the coordinates, you make an opposite. And which one do you make it? Well, if you're reflecting in the x-axis, you make the y the opposite. If you're reflecting in the y-axis, you make the x the opposite. That's easy enough. Let's look at the line y equals x. All right, the line y equals x. xy goes to yx. You switch the order of the coordinates. Let's do an example. So if you have a point A, which is at 1, 5, if you wanted to reflect it in the line y equals x, where's A prime? Well, it would be at 5, 1. All right, we're going to see in a minute what that looks like. We also have the line y equals negative x, and that's the coordinates for that. xy goes to negative y, negative x. All right, so you have these rules. You're going to have to look at it and study it. Am I going to tell you these rules? No, because you could always just graph it and figure it out yourself. But let's do let's do a parallelogram. Ooh, reflected over the line y equals negative x. All right, so do this. Graph the parallelogram and put the line y equals negative x on the graph paper, and then you can stop there and we'll do the rest together. Go! Awesome. So what did we got here? A little parallelogram going in the first quadrant, second quadrant, and on the other side of the line. Let's not forget to label our line. This is the line y equals negative x. Now remember, that kind of cuts the quadrants right in half. Goes through 0, 0, and then goes down 1 over 1, and it kind of goes through, look, this is how I do it. Like, it goes through -1, 1, -2, 2, -3, 3, -4, 4. Okay, making that little square thing. All right, so that's the line y equals negative x. I want to reflect this shape into this line, which means if I folded the paper on this line, this thing's going to end up down here somewhere. So I'm going to show you how to do it by counting, and then I'll show you how to do it without counting by using the rule that I just showed you above. All right, so here's the point A. If I go straight to the line, it goes right through the middle of that square. So you have to do that again, and it'll go on the other side right here. So this is where A prime is going to be. How about B? Well, B's right here. If I go to the line, and then on the other side, B prime will end up here. Okay, how about C? If I go straight to the line, you go through the middle to here. 1, 2. How far away is it? I lost track. It's 2 away. You got to go through 2 squares. All right, so here's C prime. And how about D? Well, you got to go through the middle again. So 1, 2, 3 and a half. That one's tricky. 1, 2, 3 and a half. So let's go half. 1, 2, 3. So that one will end up down here. Let's use our lines here and make. I'm using my straight edge. I got my straight edge going. You got your straight edge going? Got your game on with your straight edge? Ta-da! That's kind of what it looks like. Parallelogram reflected in the line y equals negative x. Now, that counting stuff can be kind of tricky. You could screw it up easily. I'm going to be honest. You could screw that up easily. Not you specifically, but one could screw that up easily. So I'm going to show you how to do it with the coordinates. Now, what's the rule? Just use the rule that I gave you. The rule is for y equals negative x, xy goes to negative y, negative x, which means you switch the coordinates and you make them negative. All right, let's try that. So we're going to switch the coordinates and make them negative. Oh, this is exciting, Mr. Kelly. Exciting. All right, so A is going to go to what? Switch the coordinates and make them negative. So that means that -2, 4 will become -4. That's the switch, and make -2. All right, so that became the x, that became the y, and we made them both the opposite. Let's try it with B. All right, -3, 2. If we want to map to B prime, all right, negative 3. So switch it would be 2, negative 3, and then you need to make them opposite. Negative 2, positive 3. Negative 2, positive 3. Oh, maybe this way is easier for you. 1, 3. So 1, 3 is going to go to negative 3, negative 1. All right, how about D? 2, 5. So 2, 5 goes to, ta-da, negative 5, negative 2. All right, now let's write down what our rule is so we know what we did there. That xy is going to negative y, negative x. So I'm going to plot these points. Let me plot them in green here to see what it looks like. So A prime, negative 4, 2. 1, 2, 3, 4, 1, 2. That's this point right here, A prime. B prime, negative 2, 3. Negative 2, 1, 2, 3. All right, there's that point. C prime, negative 3, negative 1. Negative 1, 2, 3, negative 1. All right, there's C prime. And D prime, negative 5, negative 2. So negative 5, negative 2. There's D prime. All right, so let's use our, all I have is blue. Sorry, people. I wanted the green. But we get the same shape we got before the first time. All right, so there's two ways to do that problem. You can either count. If you're good at spatial awareness, you can visualize that in your head. You can just count it and put down the coordinates, but it's probably safer to use the rule. That way you won't make an error, just a lapse in judgment, one of those type of things. All right, so try this one all by yourself. Reflect a triangle in the line x equals negative 3. Go! Okay, so I'm going over. This is the pre-image, all right, the original triangle. We want to reflect it in the line x equals negative 3. So the first thing you have to do is graph that line. Here it is, and label it x equals negative 3. Use your straight edge. Okay, now it's a counting game. All right, so from A, it's 3 units away. I think I did C first, though. Did I do C first? I don't know. Yeah, I did C first, then B, then A. Okay, we make sure that we label them. And I like the color blue, so I'm going to change them all to blue. There you go. There's your answer. And you're done. It's that simple. Do I have a rule for x equals negative 3? No, I do not have a rule. I could come up with one, but it gets past the scope of this course. I mean, it's not that difficult, but you don't have to do all that work. You can just graph it, and you can count over, and that's good enough. If it asks you for the coordinates, you have to be able to read them off of the graph. So let's do that in this case. All right, I'm going to use blue so we keep everything consistent here. So A prime is at, what do we get? 0, 2. And B prime, can you look at it? What do we get? Negative 1, 4. And C prime is at negative 2, 3. All right, so, as you notice, the y-coordinates didn't change again because you're not moving the triangle up and down, you're moving it left and right. So the last type of problem they could give you is right here. You don't even have a graph. It's just find the coordinates after a reflection in the line y equals x. Well, I knew Mr. Kelly would give us that little chart there, and y equals x. All right, so the rule is xy goes to yx. So I'm not going to graph it. Oop, that comes next. I'm not going to graph it. What do we got here? F would go to f prime. All right, so I'm going to write the rule down there so I can look at it. It always helps to look at stuff. xy goes to yx. All right, that's the rule for reflecting the line y equals x. So 5, negative 2 would go to negative 2, 5. All right, what about r? 10, 0. R prime would be at 0, 10. Okay, what about E prime? 12, negative 5. And D prime is negative 3, 0. And we're all done. I mean, that's how you do that one. You just have to know that for some lines there is a rule. The x-axis, the y-axis, y equals x and y equals negative x. All right, I'm going to leave you with Sully or Mulan or Sulan. Sulan is going to be singing for us.